I know you all have been waiting for the sessions to start, and apologies for the delay. Okay, let's start with our first session. Believe in Serverless, a hands-on serverless app integration using AWS services. And let me introduce Shravan Kumar. Shravan is a backend developer and a solution architect at Antstack. He has keen interest in working on serverless technologies like AWS Lambda, API Gateway, WebSocket, and DynamoDB. He comes with extensive expertise in JavaScript, TypeScript, and payment integrations. Shravan has also led scalable and efficient backend solutions. So he is also passionate about modernizing applications and sharing knowledge. So let me invite Shravan to the session, okay? Let's start.
Hello. Thanks for that invitation. Good morning, everyone. Hope you're all having a good day. So, my topic is believe in serverless. Hands-on, I'll be doing a app integration using a serverless technology. So, in this session, I'll be throwing some light on DynamoDB single table architecture, authorization, and WebSocket connections, and how to listen uh, webhook events from payment integration, that is Stripe. So, how many of you here come from a service-based? Hello, hello. Am I audible now? Okay. How many of you come? How many of you here come from a service-based company? That's nice. So you might be having a clients who would be rushing to do their product or the problem statement that they have built to come to a market very soon, right? So need for speed is the most wanted for most of the clients. And security, performance, and scalability is the other aspects that any client would be expecting for their application to have. So that's where the serverless technology comes into the picture. So serverless handles security, performance, scalability, and with all the due speed. So that's the architecture that I'll be walking through today. I have a Stripe integration for handling a payment. So before I start with, we have an application built. That's a reimbursement application. So I'll give a small light on what that application does. So as an employee, you would be having a reimbursement request that you need to submit for your workspace so that they would do the reimbursement. Maybe that could be a travel reimbursement or etc. So this is the admin dashboard where your admin would do a request accept or reject based on the criteria that each workspace or organization would be having. So these are the entities. I have an inbox that is directly related to the workspace. Then this is my request that is related to me as a user. This is a single request. And this users of a workspace. Now, if we look it into a relation-wise, so the request configuration and the payments are directly connected to the workspace. So considering these aspects, we can do a table design, a single table design. So let's say user logs in with the workspace ID. Now with the workspace ID, you know which workspace does that user belong to. So that's the start point. So you have a first data set that you would want to show it on the user dashboard. So that could be this thing. So how would you get this? You have a workspace, and the workspace is related to request. So, um, yep. So what comes with the data modeling is that how well you design your entities, so that there is less higher performance, less latency on the DB queries. So I would partition each, like let's like all these are entities. So each entity is connected to the workspace in some scenario, and some of entities are directly related to the user. So keeping that in the point, I'll have okay. Okay, this would be the better example. So I'll have a partition key and the sort key. That's the key elements in the DynamoDB design. So I'll when a user logs in, I have a workspace and I have the workspace ID. So I like if I use a PK, just a PK in the query, I'll be getting all the workspace that could be useful for application admins. And request is a key entity in the application that I have built. So if I have a workspace ID, let's assume I am Shravan at Antstack.io. My workspace ID would be Antstack hash request. If I query based on the PK, now I'll be getting all the requests which you see, which you saw in the inbox. Now there could be scenario where I would want to see request that is related to me. So in that case, I'll be using a partition key and starts with user ID. That's my ID. So that will render that will get the all requests that is related to me. Now, I would want to see individual request in my dashboard. I have a request ID because previously have listed all the requests. Now your client know what's the request ID. So client makes a query with the request ID, you will be getting all those that individual request. There are other entities that is directly related to request here, that is comment and history. So that's the relation that's there between sub entities, like sub entity is a request, history and comments are the part of that request. So that's where the comment and history will have a partition key with request ID. So if you look at this pattern, so what I have done here is all the entities I have put it on the partition, and the first known thing will be a sort key, and the composite second key would be ID. So that way, we are partitioning each entity to, like in a Dynamo, we are partitioning each entity to be a separate, so that there is a high performance and less latency with this query patterns. So that's the table design for this application. Okay, now let me give some scenario on how authorizer can help. Like any application that you build needs to have a authorization. In the serverless, what we can do, we can completely decouple authorizer from the business applications or the other handlers that your architecture might be having. So client makes a request, any request that comes to API gateway before it goes to authorizer, and there, based on the role or based on the routes that they are calling for, we can fine grain their accessibility to that particular route. So why Lambda custom authorizer? First thing, you can do all the customization in the authentication. What do you mean by custom authentication? You can speak to any authentication provider. That could be Google, OpenID, Connect, etc. Here in this application, we are just using a JWT to verify the authorization and do the authentication. It's like I said, it's decoupled from the application logic. So your application handlers will mainly focus on the application, not on the authorization, because authorization is entirely decoupled and handled in the authorization logic. So dynamic, what do you mean by dynamic policy generation? We have a policy in the AWS, like everybody knows it. Uh, for you to access any service or do anything in the AWS, you need to have that permission. So that's where when a user requests for a particular route, uh, let's say there could be a use case scenario where a normal user of application would you would want to restrict them from accessing the data that is related to the workspace, which is only needs to be visible to admin. So in that case, you can that's the logic that I have here. Access check. If a user is not permitted to use that route, we'll be using a deny policy. If so, that user is an admin, we can allow for a particular route. So here, by default, I have allowed it for all the routes or all the service calls. In this statement, I can fine grain to access a certain route or a certain service in the AWS environment. That way, we are doing a fine grain access using Lambda custom authorization. So there's a, there is one myth in the serverless communities that Lambda does a cold start and you would not be getting an instance response from Lambda. So there are multiple ways to mitigate this thing and make a Lambda high performative. So what is cold start? So the Lambda function that you had written will be stored in a S3. So whenever there is a request that is coming to the Lambda, it have to load that Lambda logic that you have written. That will be in a S3. It'll create that environment for your request to serve. So that init phase is what the cold start is. But once the Lambda have spawn up, the consecutive requests that we'll be getting will be served very quickly because Lambda is already in the warm start. Now, there are like by default, all your Lambdas will be unreserved. Like the common strategy that you would be using for mitigating this cold start is by using a reserved or the provision concurrency. Reserved comes at for free. Provision, you will have to pay for how many Lambdas you will be provisioning. So what do you mean by provisioning? Just now I said that init phase which Lambda have to go through when it gets a first request, right? So when you define a Lambda to be a provision, that Lambda will not be doing a init because that environment is already available for a request to serve. But that comes with the cost. So like the couple other strategies that we use in our development thing is we do a tree shaking using ES build. So what do you mean by tree shaking? Lambda would like your logic would be having a multiple dependencies, like you would be using some external libraries, helper functions, all those things. So what does tree shaking do? So you have a library. In that library, you would be using a one method or a one part of that library. So if a Lambda have that all the library content, that's where the file size is larger. But with ES build, if you are using certain method of that library, only that method will be part of your Lambda logic. That way reducing the file size. So with that, init phase is also reduced. And other strategy would be if you have a large dependency on some library, you would store that in a Lambda layer so that Lambda will have only a business logic that it needs to take care of. And another strategy is, let's say you have some routes. Those routes would be expecting very low traffic. So with that, what happens? The chances of your Lambda going back to the off state, that's the cold state, will be more. So how would you try to keep it warmer? So, like whatever the routes that have a low traffic, we would strategize to keep it in one Lambda. So that way, uh, consecutive routes will try to keep that Lambda warmer. So that's what I'm doing it here. So these are multiple routes. I have kept it in one handler. So there could be a request coming for create subscription, and it's served. Now the Lambda is in the warm state. Now there could be a consecutive request that could be getting for update subscription. Now for update subscription, Lambda doesn't have to go through the init state, because in the while it was serving a create subscription, Lambda was in warm state. That's one of a strategy that we can use it for mitigating the cold start, and for keeping Lambda warmer for longer time. Okay, so we have this architecture, all these things. So how many of you are here familiar with the NodeMon? NodeMon, yeah. So what does NodeMon do? Whatever the changes that you do it reflects real time, right? So what if you imagine whatever the changes that you make in your local system, that code gets reflected to the cloud in a real time. So that's what the SAM Accelerate does. So you'll be in this development environment where a front-end guy would be requesting for some of a API change very quickly. So would you prefer to raise a pull request for all the changes and wait for a longer time, or would you want to push those changes immediately? Because that's just a dev environment. You don't have to worry about whatever the changes that you would want to push. So that's how we can use a SAM sync and reduce the time that's required for the deployment. And another advantage of using SAM Accelerate is that every time you make a change, it doesn't need to go with the deployment steps. Like that could be through a GitHub Actions or a code build. So I'll demonstrate how the SAM sync works in the coming use cases. So my application here will be using a Stripe. So I'll quickly share how we configure the Stripe part. Presuming that we have a Stripe account, all those things. We go to the developers. The first thing that you would do is like Stripe have this thing. Any action or any change that happens in the Stripe entity, that will be sending you a response that has happened there for your handler or a server. So I have connected my route here to listen to the events that is happening in the Stripe. I have a product created here. So I am using a subscription model of a Stripe. So this is it for the Stripe configuration. Once you have this price IDs, all these things, you would copy this API keys. This secret key is for you to interact with the Stripe APIs, and this publishable key is for your client side to do the payment things. And before I start with the subscription, every entity in this Stripe comes with this metadata. So what is metadata? Metadata is a custom key value pairs that you would want to store in different entities. So what's the advantage of having that metadata is, so like I said, whenever there is a status change or whenever some event that is happening in the Stripe, Stripe will send you a send you a request with that change. So in your webhook handler, you should be knowing for which workspace or for which product the change is happening. So that's where metadata comes into the picture. So I have a workspace ID here and user ID. So I'll be knowing which workspace I have to make the change that I have listened from the Stripe. So I'll quickly demonstrate how the create subscription works and what's the edge case that would be encounter in while doing the subscription.